Hello, so in this video, we're trying to use trigonometric identities to show that this left-hand side is the same thing as this right-hand side. Now, so when I look at this to start with, this left-hand side doesn't look very easy to do anything with. Yeah, it's all in terms of sine and cosine already, so I can't even, it's not like it's cosec and sec and stuff that I can change. There's not really much to do. If I did have to manipulate this, I'd probably try to go for a common denominator first and combine the fractions, but it doesn't look very simple. If I look on the right-hand side, I can see a cosec that I can change to 1 over sine, a 2x that I can use the double angle formula for. Let's just say a double angle formula for that. And I have y minus x, which I can probably use the compound or addition formula on. So it looks to me like starting with this right-hand side is going to be a lot easier because I can just basically apply the double angle and the addition formulas to this and see where I go, and it will probably end up giving me this. So let's start with this right-hand side this time. And it's up to you which side you start with. I normally try to go for the left just because it's, an easier default, but either one is fine. So what I'm going to do is I'm going to put this cosec on the bottom first of all. So we'd have 2 sine of y minus x on top, all over sine of 2x. And as we said, we now have the addition formula here and double angle formula here. So applying all of that, this top bit is going to, put it in a big square bracket. Yeah, this top bit, if I apply the addition formula, which you're given in the formula booklet, because it's a y and an x and a minus, it's going to become 2 sets of sine y cos x minus cos y sine x. Got the little x here. So that's my numerator now. And the denominator of sine 2x, using the double angle formula, this will come out as 2 sine x cos x. Right. So I can cancel out these 2's because there's 2 on the top and the bottom. And we can write all of that a bit more neatly. So we have sine y cos x minus cos y sine x all over sine x cos x. All right. So we now need to get from here into this. So there's nothing that I can simplify from top and the bottom yet. But I know looking at this left-hand side, I'm going to have to split it into 2 fractions at some point. So that's what I'll probably do now, split it into 2 fractions. So if we scroll down a bit, that's going to mean that we get sine y cos x over sine x cos x minus this bit here, so the cos y sine x over sine x cos x. And then looking at these, now that it's simplified into 2 separate fractions, we can cancel these out and we can cancel these sine x out. So what we've got left is a sine y over sine x minus cos y over cos x, which, if we look up here, is exactly what we wanted. So that's it. We've started with this right-hand side, changed cosec into 1 over sine, applied our double and addition formulas, and basically just followed it through, simplified it until we got to the answer. Cool. So hope that made sense. If you have any questions, then let me know, and otherwise see you in the next video.